So question number one, we are factoring the expression 35x to the 16th plus 25x to the 10th minus 20x to the 7th. Now, our first move is to identify the GCF of this expression, the greatest common factor. So the greatest common factor here, GCF, is equal to the GCF of the coefficient, that is 5, and all the variables, including, but you will need to take the one with the least exponent. So in this case, we only have one variable, that is x. X exponent 7 is the least exponent. 7 is the least exponent. So the GCF will be 5x to the 7th. So what you have to understand is that the GCF includes the variable if the variable is common. In this case, x is common throughout the expression. So x with the least exponent 7. Now that we identify the GCF, we're going to factor it out. So factor out the GCF, 5x to the 7th times. Now the first term of the expression is 35x to the 16th. We need to find the number. We need to divide the expression here by 5x to the 7th. So we divide 35 by 5, that's 7. And then x to the 16th divided by x to the 7th will be x to the 16th minus 7. So that's x exponent 9. We will do the same thing for each term. We would divide by 5x to the 7th. 25 divided by 5 is 5, so that's plus 5. And then x exponent 10 minus 7 is x to the 3rd. We will do the same thing here for the last term. We will divide by 5x to the 7th. So negative 20 divided by 5 is negative 4. X exponent 7 minus 7, that's x exponent 0. And we know any number exponent 0 is 1. So that would be times 1. So you don't have to have that. So this is the factored form of 35x to the 16th plus 25x to the 10th minus x minus 20x to the 7th. The factored form is 5x to the 7th, that is the GCF, times 7x to the 9th plus 5x to the 3rd minus 4. The next example, we need to factor out the GCF. Well, for this one, they ask me to factor completely, but this one, they only want me to factor out the GCF, which is the same thing. So we factor the GCF out. First, before we factor the GCF out, we're going to identify the GCF. The GCF greatest common factor is the GCF of the coefficient of the expression is 5. And then the least exponent of the one variable that is present in the expression, the one variable is x. The least exponent is 2, so that's x to the second. Now let's factor out the GCF. 5x to the second times, let's divide by 5x to the second here. That's 5x to the second. We divide each term by 5x to the second. So that is 2x to the third plus 7x plus 15. Factor completely number 3. We will identify the GCF. In this case, we have two variables, x and y. We're going to do the same thing. GCF will be the GCF of the coefficient, which is 3. The least exponent of x, x4, x5, x3. So that's x3. Least exponent is 3. X5, y5, y6, y4. Least exponent is 4, y to the fourth. Now we're going to factor this GCF out because they said completely. 3x to the third, y to the fourth, factored out. Then now we divide all the terms by the GCF that we found. Let's divide by 3x to the third, y to the fourth, 3x to the third, y to the fourth, 3x to the third, y to the fourth. Then the first result of the division will be 5x squared y plus, we subtract the exponent, plus 7xy squared, and then plus 3, plus 1. All right. And then next, we have this to factor by grouping. So we're going to group the first two terms together and the last two terms together. The beginning of the second group is a negative number, so I'm going to factor the negative out with the GCF. But first, let's find the GCF of each group. What is common for the first group will be the GCF of each group. So the first group here, what's common is x. We factor it out. We factor the GCF out. So when we factor x out, the first term, what's left is b. So that when we distribute, we get b. And then there's a minus 6. Obviously, if we factor if we distribute the x again, it would give you xb minus 6x, right? Which is great. So we factor it out. Now let's factor out -9. We keep the negative with the 9 out because the first term has the negative sign. If both of them had the negative sign, we would have done the same thing. Whenever the beginning term of the group has a negative sign, you always want to factor that negative out because you want to keep the the first term with a positive coefficient. So let's factor out negative 9. So negative 9b divided by 9 is b, minus, because you're gonna divide 54 by negative 9. The result will be negative 6. So now, as you can see, the expression b minus c 6 is now common throughout the expression, or is the common factor for both groups. Now we can pull out that GCF, that factor here, b minus 6. We're gonna pull it out. Let's factor out the b minus 6, the factor b minus 6. And then the other factor will be x minus 9, what's left. All right, so that's the factored form of the expression xb minus 6b minus 6x minus 9b plus 54, obviously by grouping. Let's do the same thing with this next problem, number 5. We group and we factor the GCF, which is y y factored out, x plus 4, we factor 7 out, x plus 4, and then the final answer, when we factor x plus 4 out, the other factor would be y minus 7. Let's try this one. Group the first two terms and the last two. GCF is, well, obviously, one thing we can do here first is to check for the GCF. Since I'm looking at this, I see that all the terms are a multiple of 4. So let me factor 4 out. 4 times not 4, 2. So that's 2 times 2x squared minus 15x plus 2x. So the first term, that's 5. 5x squared minus, because you divide by 2, right? You divide by 2. So that's 5x squared minus 15x plus 2x minus 6. Well, obviously, you can see that the two terms in the middle, you could combine. But in this case, I would say no with the combine, because you want 4 terms to be able to factor by grouping. And if you combine these two, you won't have the 4 terms that you need. So that's why you're not going to combine here. You're going to make sure that you keep the terms separated. Now let's group these two and these two. Factor out the GCF. Obviously, we would keep 2 here, the 2 that we had here. I'm going to work with this part inside of the parentheses to factor. So if you factor the GCF of the first group, that is 5x, factor x minus 3. Let me factor 2 out here, x minus 3. I can factor the x minus 3 with the factor 2 here that we factored completely out. X minus 3 times 5x plus 2, which is the final answer. Number 7, we will process the same way. We'll do it the same way, but as you can see, we do not have the 4 terms. So we will generate the 4th term by multiplying the coefficient of the quadratic term. So basically, you know, the quadratic, that's a quadratic expression written in the form ax squared plus bx plus c. Now to generate the 4th term, the one more term for the expression, you're going to multiply a and c. And then, so in this case, it's a and c, that's 54. Now we will factor a times c. We will factor, this case, it's 54. We'll factor 54 in 2 factors, 2 numbers that the sum is 15. So 54 has 2 factors, the sum is 15. So it might take you some time to find the 2 factors. So for example, if we take 9 and 6, 9 times 6 equals 54, and 9 plus 6 equals 15. So 9 and 6 are the right numbers to use in this case. So once we get that, instead of 15x, we're going to write, instead of 15z, we're going to write 9z plus 6z. The expression will be z squared plus 9z plus 6z plus 54. Now, obviously, you see that we have 4 terms that is required to factor by grouping. Now, my first group will be the first 2 terms, and my second group will be the last 2 terms. And now let's factor the GCF of the first group out. GCF of the first group is z. We factor it out. I'm left with z plus 9. And the GCF of the second group is 6 plus 6, z plus 9. And again, you can see how the z plus 9 factor repeats for both groups. We can factor z plus 9 out, and what's left will be z plus 6. Then we get the answer here. Let's try the next one, the next example. So the coefficient of the quadratic term, that's the quadratic term. The coefficient of the quadratic term in this case is 1. We're going to multiply coefficient of quadratic term by the constant. 1 times negative 6 is negative, 1 times negative 36 is negative 36. Now, 2 factors of negative 36, that the sum is negative 5. So, because it's negative, one of the factors will be negative, because that's the only way you can get a negative number, by multiplying a positive number and a negative number. Now, we will need to add them to get negative 5. So we're going to have a positive number times a negative number that when we add, that should give me a negative result. So the larger number, the bigger number must be negative. So if I use 9 and 4, 1 needs to be negative, but that's the bigger number that needs to be negative, so that when we add, we have a negative result. So negative 9. Negative 9 times negative 4 clearly is negative 36. And negative 9 plus 4 is clearly negative 5. So we get the numbers. We can write the 4-term expression that is needed here. So z squared minus 9z plus 4z, which is negative 5z, minus 36. First group, second group, GCF of the first group, z. That's z minus 9 plus GCF of the second group, 4. Z minus 9. We can factor z minus 9. And then the second factor is z plus 4. Okay. Move on to the next one. Coefficient again is 1. We will multiply 1 and negative 63. That is negative 63. Need 2 factors that the sum is negative 2. The 2 factors will be, the 2 factors that the sum is negative 3 will be 7 and negative 9, right? When we multiply, clearly it's negative 63. When we add negative 9 and 7, the result is negative 2. So that's x squared minus 9x plus 7x, which is negative 2x, minus 63, first and second group, x out, x minus 9, 7 out, x minus 9. So x minus 9 times x minus 9 times x plus 7. Okay. Now, the next example here, number 10, we can do the same thing, but in this case, it's not the constant and the quadratic coefficient. It's just going to be the coefficient of the square term here times the coefficient of the beginning squared term and the coefficient of the ending squared term, right? So we will multiply 1 and negative 30. coefficient of the beginning squared term and the coefficient of the other squared term, which is the ending squared term. So that's negative 30. We need two factors of negative 30 that the sum is 7. The sum is 7. So the two factors will be, we need a positive number result in this case. Well, two numbers that when you multiply giving you a negative result, that's two numbers with opposite signs, right? One positive, one negative. Now we need a result when we add them to that is positive. So the bigger number is going to take the positive sign this time. So that is 7, sorry, that's 10 and negative 3, right? So when we multiply the two, it's negative 30. But when we add 10 and negative 3, it's going to be positive 7. So now we can rewrite this expression as x squared plus 10xy, because the middle term is xy, is 7xy. So we break it down as 10xy minus 3xy. And then minus 30y squared. Now, 4 terms, we're going to group and factor by grouping. That's my first group, and that's my second group. Factor the GCF of the first group, that's x. So I'm going to factor out the x plus 10y. The second group, GCF is negative 3y. So that is x plus 10y. Then factor out the x plus 10y. And then what's left is x minus 3y. Same thing here, but we want to check to see if there is a common factor to pull out. In this case, I believe 4 is probably the common factor. Let me factor 4 out. It's 4 times x squared plus 2x minus 35. Now, we're going to multiply the coefficient 1 of x by negative 35. So that's negative 35, right? So that we need to find two factors of negative 35 that the sum should be 2 positive. So the larger factor will be positive. One would be negative, one will be positive, but the one with the larger one would be positive. So 7 and negative 5. When we multiply, that's negative 35. 7 minus 5. When we add, it's 2. So we know that we're going to preserve the 4 for the final factored form. So I'm going to work with the part inside of the parentheses to write the 4 terms. So that is x squared plus 7x minus 5x minus 35. First group, second group. GCF is x for the first group, x plus 7. And GCF of the second group, negative 5. x plus 7. Then we factor completely the x plus 7, and we keep the 4 as with the final answer. That's 4 times x plus 7 times x minus 5. The next example, number 12, we check for the GCF also. The GCF here is 7x. GCF is 7x. Let me factor my 7x out. So I'm left with x squared plus 3x minus 10. Multiply coefficient of x squared by the constant, that's negative 10. Two factors of negative 10, that the sum is 3. So that's 5, negative 2. When we multiply, that's negative 10. But when we add, it's positive 3, which is great. Now, let's go ahead and break down the middle term here as 5x minus 2x, so we can factor. And then the final answer we know would keep the 7x out. So that will be x squared plus 5x minus 2x minus 10. And then if we group, the first group will be x squared plus 5x. The second group would be negative 2x minus 10. GCF of the first group is x. So that's x times x plus 5. The second group, negative 2 out, x plus 5. And then completely, we can pull out the GCF, the 5 plus x. So that's 5, the x plus 5, the x plus 5, and then what's left is x minus 2. So the final answer is 7x times x plus 5 times x minus 2. The next example is one that we've done like it so far. We've done problems, I think one of the numbers here, 10. Number 10 was the same. So we're going to do this. We multiply the coefficient of x squared by the coefficient of y squared. That's negative 15. Two factors of negative 15 that add up to 2. So that is negative 3 times 5. When we multiply, that's negative 15. When we add, that's positive 2. So that will be, we would break the 2xy down to negative 3xy plus 5xy. Everything else remains the same. So x squared plus 5xy minus 3xy minus 15y squared. First group and second group, we get the GCF of the first group is x. So that's x plus 5y. GCF of the second group, I would call it negative 3y. So that is x plus 5y, x plus 5y out. And then what's left is x minus 3y. Same scenario here. We will multiply 2 and negative 15. The coefficient of the squared term, the quadratic term, we would multiply it by the constant. That gives me 15, negative 30. Two factors of negative 30 that the sum is 1 will be 6 and negative 5. When we multiply, that's negative 30. When we add, that is 1. So that works. Bring it here. So that's 2w squared plus 6w minus 5w minus 15. First two terms will be the first group, and the second two term will be the second group. Then we have the GCF of the first group is 2w. So w plus 3. Negative 5 is the GCF of the second group. Factor it out, w plus 3. W plus 3 factored out. What's left is 2w minus 5. We will continue to do that, the same scenario here. So we'll go a little faster here. Multiply 6 and negative 12. That will give you negative 72. We need two numbers that when you multiply, so we multiply 6 times negative 12, that equals 72, negative 72. Now we need two factors that when multiplied, they give you negative 72. And then when you add them, you want to get negative 1. And these two numbers will be negative 9 and positive 8. Negative 9 and positive 8. So when we multiply, that's clearly negative 72. But when we add, it is negative 1. So coming here, that the three-term expression will become 6y squared minus 9y plus 8y, which is negative 1y, minus 12. First group, GCF is 3y, so that is 2y minus 3. The second group, GCF, would be 4 plus 4. So 2y minus 3. 2y minus 3 is the common factor for both groups. So we can factor the 2y minus 3 out. What's left is 3y plus 4. So that completes the factoring. Move on to the next one. Check for the GCF here. 3 is the common factor. Let me factor it out. 3 3 times 6y squared minus y and minus 2. Now, I know that the final, and I would factor this expression inside of the parentheses as we did for all these ones. We will, and then keep the GCF out. The GCF remains 3. I'm going to keep it here so I won't forget it, because there are temptation to forget that, and it's not the same answer when you forget it. So that's why I just leave it below so I can remember it. So when multiply 6 and negative 2, that's negative 12. Negative 12. Well, let me put 6 times negative 2 is negative 12. Two factors of negative 12 that the sum is negative 1 are negative 4 and 3, right? When we multiply, that's negative 12, but when we add, that is negative 1, right? So I'm gonna bring it here so I can factor by grouping. So that's 6y squared minus 4y plus 3y minus 2, right? So two groups, I'm gonna think about factoring the GCF out. The GCF is, for each group, the GCF of the first group will be 2y and factored out. So that'd be 3y minus 2. And the second one, well, I'll factor 1 out. So 3y minus 2, because it's already 3y minus 2. And my final answer is going to be, my final answer is 3, that 3 that was outside waiting, times 3y minus 2 times 2y plus 1, right? So that is my final answer. Move on to the next one. Always make sure you search if any GCF. If any GCF. So the GCF here is 3x squared. Let's factor it out. Factor the GCF out. 3x squared. We factor it out. Then you were gonna have 6x squared minus 13x plus 6, right? Just like we did in the previous examples, I'm gonna just remember the 3x squared will be left with the final answer after I factor the part inside of the parentheses. So I can work with it as a ignore the 3x squared for this moment, just to work with the part inside of the parentheses. Now, for the part inside of the parentheses, let's multiply 6 and 6. That is 36. 6 times 6 is 36. Need two factors of 36 that the sum is negative 13. Now, pay attention to this because you are multiplying. You have a positive number that you want the sum to come out being a negative result. Now, the only way you can get it is for the two factors to be negative, right? So you want the two factors to be negative. Well, -9 and -4 would make the deal, because if I multiply these two numbers, it will be positive 36. And then if we add -9 and -4, it's going to be -13, which is perfect. So that said, we're going to break down this into 6x squared minus 9x minus 4x plus 6. And then the two groups, you have the first group that is 6x squared minus 9x, and the second group is -4x plus 3 plus 6. GCF of the first group would be 3x. When we factor it out, that is 2x minus 3. The second group, I can factor -2 out. 2x minus 3. Then 2x minus 3 would be the common factor. 2x minus 3 that I can factor out again, but I'm going to keep the 3x squared that I had outside with the final answer. So that's 2x minus 3 times 3x minus 2 is the final answer for number 17. We'll always, whenever it says to factor completely, we need to make sure we look for GCF. If the GCF is 1, then we are fine, we can move on. But if it's not 1, you must factor the GCF also out and then proceed to the same the way we do it, since in this case we already have 4 terms. Now the GCF here, I can see that 12 is common here. I mean, not 12, 4 is common here. So we can factor out 4. But I always tend to factor the term, that the negative factor, if the first term has a negative coefficient, I always tend to pull it out as well. So that's why I'm gonna factor -4 out. -4, and then there's y in all the factors, so I'm gonna include y in the GCF. So here the GCF is -4 y. Well, if you say for y, it's not going to be a problem, but I only include the negative sign with the GCF just because the first term has a negative sign, and I always want to clear the negative sign from the first term. And now let's factor the -4y out. It's going to be 3y squared 3y squared plus, minus 3y squared minus, we divide by -4, so -6y, -6y divide by 4, so that's -4, so that's 2y, and then divide by -4, so that's -4 close parentheses. Now let's go ahead and factor by grouping. We know that the final negative 4y will be with the outside expression. The first group would be this, and that's my second group. GCF can be 3y times y minus 2, and then GCF is 2y minus 2, and then factor y minus 2. What's left is 3y plus 2. Okay. The next example here, we want to check to see if there is a GCF that's not 1. GCF is not 1 here. It's 4y. Let's factor the GCF out. So 4y times 3x squared plus 10x plus 3. We're going to multiply the constant and the coefficient of the quadratic term. That is 9, right? 3 times 3 equals 9. Now, two factors of 9, that the sum is 10. So that's 1 times 9. That when you multiply, that's clearly 9, but when you add 1 and 9, it's 10, right? So I'm going to leave that 4y for the final step of the process, but I'm going to work with this part. 3x squared plus 9x plus x plus 3. The first two terms will be my first group. The last two terms will be my second group. GCF of the first group will be 3x, right? So that's x plus 3. GCF of the second group, that's just 1, x plus 3. Now, if I factor my x plus 3 out with the 4y being on the outside, so x plus 3 times 3x plus 1 is the final answer. Okay. Now, next, let's work with the next problem, number 20. So we will multiply the coefficient of x squared by the constant. That leads to 25 times 21. Now, if you multiply, obviously, it will give you a pretty huge number. So that's why instead, I'm going to play with the factors of 21. Well, let me see what it gives me. 25 times 21 is 525. Well, this number here, we're gonna try to break it down, but an easier way to do that is to think of, well, 25 is 5 times 5 in smaller bytes, and that's 3 times 7, right? Well, those four numbers, if you multiply them, obviously it will be the 225. But I break it down in smaller bytes, and then now I'm gonna play with them to see we can switch those factors as we want, match them with each other to see which one which pair, when we multiply, that would give you negative 50. So I see if I pair 7 and 5, I will get 35, right? If I pair 7 and 5, I would get 35. And then if I pair 5 and 3, if I pair 5 and 3, I'll get 15, right? Well, that's nice, right? So that is 15, and then that is 35. Well, when we multiply this, we obviously will get 525. And then when we multiply, we get 525. And then I believe it's clear that if we add 15, if we add them, we will get, if we multiply, we will get 525. And then if we multiply, we get 525. And if we add, we would get 50, right? We will get 50. But we want negative 50, so we would just put a negative sign with these, right? So that's negative 15 and negative 35. So now that we have the numbers that we needed, well, obviously what I showed you here is not what you must do. I'm just trying to give you easy way to not getting yourself in trouble with a big number. Now, every time you get a bigger number, it makes it harder for you to get the coefficient, the two factors. So that's why I showed you this little trick to play with it. But if it's not convenient, well, go ahead and do however you want to do it. That's fine. Now that we get the numbers, let's write them in the equation. So that will be 25x squared. I'll put minus 15x here, minus 35x, and then plus 21. With that, we can factor by group and factor the GCF of each group. First group is the first two terms, and second group is the last two terms. So let's factor the GCF of the first group, that is 5x. So that's 5x minus 3. GCF of the second group will be I believe 7. So that's I put the 7 minus 7 out. So that is 5x minus 3. If we factor 5x minus 3 out, then that's 5x minus 7. Now, The next example, number 21, it's still a quadratic expression, but what happens is I'm seeing two terms, right? So the quadratic expression in complete uh, form is expected to be ax squared plus bx plus c. But in this case, the b term is missing. Now, when it's missing, first thing to do is to check for the GCF if it's not 1. In this case, the GCF is 3. So we can factor that GCF out. That's 3 times x squared minus 4. Well, we need to remember that can be seen as 2 squared, right? So the reason I want you to see 4 as 2 squared is because I want to talk about the difference of squares, which is the formula that allows you to factor if the two terms are squared and then a difference. If you have a difference of squares, the factor would be just square root of the first one plus the second one times square root of the first one times the square root of the second one times square root of the first one minus the square root of the second one. So what I said here is that you can just think about dropping the exponent squares, the squares, and multiply the two things, but the first factor, one of the factors will be adding the two numbers, and then the other factor will be subtracting the two numbers. So drop the powers, add the numbers, and subtract them to create the two factors. In this case, you can see this as 3 times, let me put that here, as 3 times x minus 2 squared, right? So that is x squared. So if I remove the power 2's, I'm going to be left with 3x plus 2. I'm applying this formula times x minus 2. But first, you want to put your expression in difference of, first you want to factor the GCF and then see if you can put it in the format of difference of squares. And when you do that, it allows you to apply the difference of squares formula. So that is your final answer. Next example, 22. Let's see, we will multiply the coefficients of the quadratic term by the constant term. Now here, what I have is 16 times 81. I'm going to play with it the same way I did with the big numbers. Whenever I'm getting big numbers, I don't want to deal with that. So I'm going to break it into smaller bites. So 16 times 81 is expected to be 1,296. Now, breaking this down to find the factors will be a long process, which we don't want to get ourselves into. That's why I'm trying to break this down in smaller bites, so at least I can find out what is it without having to go through all these pen. So that's 4 times 4, right? And then that is 9 times 9. Let me match. I'm gonna match. I'm going to match 4 and 9. Well, obviously 4 and 9, 4 and 9. And then, so that will be 36, 36. That, that's 36. And this one will be 36, right? So this will be 36. 36 times 36. Yes, when we multiply, it will be that number here. And then if you add, would it be 72? Yes. So 36 plus 36 is 72, which is perfect. Now go back to the equation. I'm going to write 16t squared plus 36t plus another 36t plus 81. Now that is I can factor, let me factor 4t out. So that's 4t plus 9 plus, I can factor 9 out. That is 4t plus 9. See that I can factor 4t plus 9 out again. So that's going to be another 4t plus 9. Since this expression multiplies twice, it becomes 4t plus 9 squared. Yes. Now let's the next one. Let's try to factor the GCF, if any. We want to make sure that we check if there is a GCF somewhere, right? The GCF will be 3W. We're gonna pull it out. 3W. 3W times W squared plus 14W plus 49. Okay. So now with that, what we can do is we can keep the 3W for the final step, right? And then multiply 1 and 49. So that is 49, 7 and 7. So that's gonna be that's gonna be W squared plus 14W plus instead of 14W, I'm gonna use 7 plus another 7W plus 49. Factor the GCF of the first group, W. That is W plus 7. GCF of the second group, I'll call it 7. W plus 7. So then that's going to be W plus 7 times W plus 7 with the 3W, right? But W plus 7 plus W plus times W plus 7 will be just W plus 7 squared. So that's 3W times W plus 7 squared. Okay. Now we have another situation where we have a difference of squares, but check to see first if there is a GCF that's not 1. In this case, GCF is 1. All we want to do is to make sure that the expression is well written so we can identify the base of each squares. So identify A and B in the problem. So instead of 9x squared, because we know 9 is 3 squared, so that's going to be 3x, the whole thing squared, minus 4. 4 is 2 squared. Now I see the difference of 2 squares and I can identify A and B. Now A will be 3x and B is 2, right? And then we can apply the difference of squares nicely. So that is 3x plus 2 times 3x minus 2. This next example, it's a complete quadratic expression. So we're gonna multiply the coefficient of x squared, the squared term, or the quadratic coefficient of the quadratic term by the constant. Here that is 64 times 25. Same thing happened. I'm gonna piece it into smaller bite. So that is 8 times 8, 5 times 5. So 8 times 5, 40. So that's gonna be 40 and 40. So the product, if you want, that is going to be 64 times 25. That is 1,600. I'm gonna cut 40 and 40, but both of them will be negative, right? So the sum will be negative 80, and then the product is positive 1,600. So I'm gonna bring them back in the equation. 64x squared minus 40x, another minus 40x, plus 25. Group the first two terms and factor the GCF 8x out. So that is 8x minus 5. Factor the GCF of the second group. That's minus 5x minus 5. 8x minus 5. Now 8x minus 5 can be factored out. That's 8x minus 5 times another 8x minus 5, which is the same expression. So I can write it as 8x minus 5 squared. Now that I have my expression fully factored, that's this, then let's move to the next example. The next example, it calls for the sum for the sum or a difference of a cube. Sum or difference of a cube. So the sum of a cube, we discussed that in class, how to identify the formulas. So this one we can write it as, we first need to identify the cubes, right? So x cubed, but this one we don't have the cube. But we know that 1 raised to any power would still be 1. So we can write this as x to the third plus 1 to the third. Now we have the sum of 2 cubes. So we're going to use this. We're going to use this formula in this case, right? Because it's the sum. We use the sum when you have a sum. You use a difference when you have the difference. So in this case, it's the sum. Let me draw my parentheses. One would be smaller, one would be bigger, because the second one has 3 terms in the formula. First thing we do is we remove the exponents, and then that goes in the first set of parentheses. The first term of the second set of parentheses is built by dropping the exponent 1 unit from the exponent of the first term. That's my first term. I'm going to drop the exponent once, it becomes x squared. Now, the second term, if it's the sum, then the second term will have a negative sign. So that's minus, and then multiply a and b. You see, a times b. So that's a, that's b. So that's x. And then the final term of the second set is the second term. We drop the exponent once. So that's 1 squared, which is still 1. So plus 1. So that is the factored form of x cubed plus 1. Okay, here's another example. In this case, we need to make sure that we see the actual base, or we see the powers. So now this is 8. Now we need to think about, what do you cube to get 8? So that's 2 cubed. Instead of 2 cubed z cubed, I'm going to write 2z cubed. Well, obviously it's 2 cubed z cubed, right? I just want it to be seen as I identify my a cubed, right? So that's a. And then the minus, so we know that we're going to use the negative, the minus, the difference formula. What do you cube to get 125? Take the cube root of it using your calculator. So that's going to be 5 minus 5 to the third. Now, we're going to use the formula, one smaller set and then bigger one here. We drop the exponent. So that's 2z minus 5. 1 unit from the exponent of the first term. I'm going to have 2z squared, which is 4z squared, right? Because we distribute the power. And then we will have a plus sign, because it's the minus formula. The second set only has plus. Then we multiply a and b, right? That's the b. We multiply a and B, that's plus 10. We don't use the sign, by the way. So that's plus 10, 10z, and then take the power down once for the second term. So that's 25. So that is the factored form of this expression. Now, last number 28. Here we have this. Let's write it in the form that we can see the base and the exponent 3. So I'm gonna write it as exponent 3. It's a minus, so exponent 3 again here. Now take the cube root of this and then divide by 3. So that'd be x squared. Cube root of 125 is 5. Minus cube root of 64 is 4. And then divide by 3, that's y3. Now we have A, that's A, and that's B. And we can apply the difference formula, right? So that is the first smaller set, and then the larger set. Okay? So smaller set, we know that we're gonna drop the exponent 3's. Oh, that's 2. So that is 5x squared minus 4y squared. We take down the exponent 3 once. So basically it will be 5x squared squared. So that is 25x4. We know it's a difference formula, so everything will be plus times A and B, so that is 20x squared y squared. Need more room. And then that will be plus, take down the exponent of the last cube once, so that is 4y2 squared. So that turns to 16y4. So that is the factored form of that one of 125 x to the 6 minus 64x y to the 6. So this next problem is number 29, is about solving equations by factoring. Solving quadratic equations by factoring. Now, first thing to do when solving an equation by factoring, a quadratic equation by factoring, we need to write the equation in standard form. Standard form is this form here, when you have ax squared plus bx plus c equals 0. So you must have all the expression on one side and then 0 on the other side of the equation. Now, once you have that, you can see how the left side or one side of the equation is one of the quadratic expressions that we were factoring earlier in this practice test. So you're gonna factor this expression the same way. And once you do that, you can use the so you would the next step after factoring the expression is to use the zero product principle or zero product property to solve the equation. The zero product property is it states that if you have a product of two factors or more factors, but the minimum two factors, if you have the product equals 0, then each factor can be solved equals 0 separately. Here's an example. I have the product 2x plus 5 times x minus 7 equals 0. So what I did, using the zero product principle, I set 2x plus 5 equals 0 and solve it to get x equals -5/2. And then I solve x minus 7, the second factor, equals 0, and then solve it to get x equals 7. So I have two solutions for this equation that are -5/7 over -5/2, 7. So these are the two solutions of the equation. So now basically we're going to go through the steps to solve this one. Since this one is not in the format that we want and we can't use the zero product principle yet because this is not a 0. You can only do zero product principle with 0 on the left, on the right, and then the expression on the left or any side. Let's go ahead and distribute the m here over the terms inside of the parentheses. So that will give me an equation m squared plus 9m. And then if we add 14 on both sides of the equation, that will be plus 14 equals 0, right? So now we can factor this by writing, if we get 14, two factors of 14 that add up to 9 or 7 times 2. So that's m squared plus 2m plus 7m plus 14 equals 0. M is the common factor times, for the first group, m plus 2 plus 7 m plus 2 equals 0. So that'd be m plus 2 times m plus 7 equals 0. Now we're going to use the zero product principle. So then that is m plus 2 equals 0. Subtract 2. M equals -2. Or m plus 7 equals 0. If we subtract 7 on both sides, m equals -7. So the solution set is -2, -7. So let's go with the next example. It's already in standard form, so we can just factor and then solve by factoring. Factor and then use the zero product principle. So let's multiply -7 by -30. that is negative 7 times negative 30 is, let's see, what is it? Seven times, change color here. 7 times negative 30 equals negative 210. So negative 210, we need two factors that add up to 29. So that's 35 and negative 6. Okay, so with that, we can go back here to write 7x squared plus 35x minus 6x minus 30 equals 0. We can group and factor the GCF of each group. 7x is the GCF of the first group, x plus 5. The second group, negative 6, x plus 5 equals 0. X plus 5 times 7x minus 6 equals 0. So we have two factors that we can solve each separately equals 0 using the zero product principle. So that is x plus 5 equals 0, or 7x minus 6 equals 0. So we can subtract 5. That's x equals negative 5. And then we can add 6 on both sides. 7x equals 6. Divide both sides by 7. X equals 6 over 7. Your solution set is negative 5, 6 over 7. All right, so next example here, our next example is not in standard form yet, so we're gonna add 14x and add 48 on both sides of the equation. So that gives you x squared plus 14x plus 48 equals 0. Now 1 times 48 is 48. Two factors that multiply to give you 48 and add to give you 14, or 6 and 8. So that's x squared plus 6x plus 8x plus 48 equals 0. GCF of the first group, the first two terms, is x plus 6, plus factor 8 out from the second group, x plus 6 equals 0. X plus 6 times x plus 8 equals 0. Then we're going to solve x plus 6 equals 0, or x plus 8 equals 0. Subtract 6 on both sides, x equals negative 6. subtract 8 on both sides, x equals -8, which gives the solution set -6, -8. -6, -8 is the solution set. All right, so next we will solve this one. This one is already in standard form. We can multiply 8 and -3. 8 times -3. 8 times -3 is -24. Two factors of -24, that the sum is -2, that's -6 and +4, right? So let's factor, let's write 8x squared, 8x squared, minus 2x minus 3 equal minus 3 minus, no, let's break down that. So that's -6x plus 4x minus 3 equals 0. We group and factor the GCF of each group. The first group GCF would be 2x. So that's 4x minus 3. GCF for the second group, that I'm gonna pull out 1. 4x minus 3 equals 0. So 4x minus 3 times 2x plus 1 equals 0. So if we solve each 4x minus 3 equals 0, or x, 2x plus 1 equals 0, we're going to have, by adding 3 on both sides, 4x equals 3, or by subtracting 1 on both sides, 2x equals -1. If we divide by 4 here and divide by 2 here, we get x equals 3/4, or x equals -1/2. So we're gonna have a solution set that is 3/4 or -1/2. Okay. And then next, we will check to see if there's a GCF. Since this is a cube, but we are solving quadratic equation, that's a sign that we may have a common factor that includes the variable x, right? So let me factor out x. So that's 15x squared plus 17x plus 4 equals 0. So we can solve this x equals 0, or because it's still a factor, a product of this one, this factor, and this is another factor. So you can apply the zero product principle to that too. 15x squared plus 17x plus 4 equals 0. With that, we can solve, we can multiply 4 and 15. That will give you 60 two factors of 60 that the sum is 17 are 12 and 5. So that will be 15x squared plus 12x. Let me put the 5 first. It doesn't matter, it will give you the same answer. Plus 12x plus 4 equals 0. Now factor the GCF from the first first group. 5x, 3x plus 1 plus this time 4, 3x plus 1 equals 0. So factor the 3x plus 1. That'd be 5x plus 4 equals 0. And then now we can solve 3x plus 1 equals 0 or 5x plus 4 equals 0. By subtracting 1 on this side, on both sides of this equation, and subtract 4 on both sides of this one, we get 3x equals -1, 5x equals -4, and by dividing by 3 for the first equation and divide by 5 on the second one, we get x equals -1/3 and or x equals -4/5. So we have three solutions: x equals 0, x equals -1/3, x equals -4/5, and the solution set will be the 3, 0, -1/3, -4/5. That is the solution set. Now let's solve a radical equation. When solving radical equations, you must isolate the radical. Isolate the radical, get it by itself. So we would add 5 on both sides. So we have the square root of x minus 17 equals positive 4. So then we can raise both sides to the second power here, since the square root, if it was a cube root, you would raise to the third power, like whatever the index of the radical was or is, you would need to raise to this power on both sides. So that cancels the radical. That's the purpose of raising to the second power here. X plus 17 equals 16. I would minus 17. X minus 17. So let me add 17 on both sides. So x equals 33. Now we need to check for if this solution is an extreme solution. So we should check for extreme solution. So an extreme solution is a solution that you get from the equation, but when you plug it in, it does not verify your equation. In this case, you cannot consider this value as the solution of the equation. So that's why you need to always check for extraneous solution. So let's go ahead and check if this is extraneous. We will plug in 33 for x. So that's the square root of 33 minus 17 minus 5. Is it -1? So now we're gonna try to make sure that both sides end up being the same number. So square root of 16 minus 5, is it -1? So that's 4 minus 1. Is it -1? -1 is -1, so it checks. So now my solution set is, the solution of the equation is 33 because I verify it. And you should do, that is square root of 3x plus 15 equals 17. We would raise both sides to the power to cancel the radical. 3x plus 15 equals the square root, the square of 17 is 274. It's 289. Subtract 15 on both sides. We get 3x equals 274. And then divide by, if we divide by 3, we get x equals 274 over 3. Keep it as a fraction. Do not divide it, because it will give you a decimal number, which we don't use approximate values. So we're not using approximation. So that's why the answer, if it's in a you need to keep it as a irreducible fraction. So now let's check for extraneous solution. We will check this for extraneous solution. So we would plug in, so square root of 3 times 274 over 3 minus plus 15. Is it minus plus 15 minus 10? Is it 7? Now that is square root of that cancels this. 274 plus 15 is 289 minus 10. Is it 7? So that's 17 minus 10. Is it 7? So clearly we get the same number on both sides, which is 7 equals 7. This is checked. So the solution is 274 over 3. (274 over 3 is the solution. In number 36, here we are solving a quadratic equation by using the square root principle. So whenever you have a term or a group of term raised to the second power, you can isolate that group of term and then take the square root of both sides to solve the equation. And that's called the square root property. Now you have to remember, if you have something squared equals another number here, then you will have two solutions. The thing that was squared without the square equals the square root of the other side of the equation, or the thing that was squared without the square equals minus the square root of the other side of the equation. So basically, having 5x s squared, s minus 5 squared equals 25, using the square root principle, it implies that the expression inside of the square, which is 5s minus 5, equals the square root of 5, that is, sorry, the square root of 25, that is 5, or 5s minus 5 equals the square root minus the square root of 25, that is -5. Now you have the two equations that we're gonna solve to get the solutions of the equation. So that is, we can add 5, so 5s, if we add 5 on both sides, 5s equals 10. By dividing by 5, sorry, by 5, we get s equals 2. That's one solution. This one here, we would add 5 on both sides. So that's 5s equals 0. By dividing by 5, 0 divided by 5 is s equals 0. So you have two solutions, and your solution set is 0, 2. Next, same thing here. We're going to try to isolate this part here before we take the square root. We use the square root principle. So first, let's subtract 6. That is 2 times x minus 3 squared equals 32. Divide both sides by this coefficient 2. We get x minus 3 equals 16. And then we can use the square root principle to get two equations, right? That square here. So that's x minus 3 equals square root of 16 is 4, or x minus 3 equals negative square root of 16, that is 4. By adding 3 on both sides here, x equals 7. By adding 3 on both sides here, x equals -1. And the solution set here is 7, -1. Now, for this one, they said they want you to solve this to determine all real number solutions. Well, obviously, I'm going to solve this completely. So let's subtract the 360 on both sides. 2y squared equals -360. Divide by 2, y squared equals negative, y squared equals -180. And then y equals negative square root of -180. or y equals negative square root of 180. Square root of 180, if we factor the 180, that's 2 times 90, 2 times 45, 3 times 15, 3 times 5. And then here I can pull out a 2, can pull out a 3. So that gives me a 6 on the outside, and then square root of 5. Now, because it's negative, you will have because it's negative, this one will be y equals, because inside is negative, so it will be I, because you have a negative sign here. So that'd be 6i square root of 5. And this one would be negative 6i square root of 5. Now, if you have I, these are not real numbers. They are complex numbers. Or since they asked me to solve this, to find all real numbers solutions, not complex numbers, we have no solution that is real. So that's why this will have no solution, and your solution set will be DNA. There's no real solution because they wanted it all real numbers. They wanted real numbers, not complex numbers. Now let's see how it goes for the other equation. For this equation, that second equation, we're gonna add, let's add 225 on both sides. So we would get 3s squared equals 225. 2s squared equals 225. And then we can divide both sides by 3. When we divide both sides by 3, we get s squared equals 75. And then we got two solutions. S equals square root of 75, or s equals negative square root of 75. Now, 75 can be factored as 3 times 25, 5. Same thing here. So 1 5 goes out. 1 5 goes out. So that is 5 square root of 3. And this one will be negative 5 square root of 3. So s equals 5 square root of 3, or s equals negative 5 square root of 3. So your solution set becomes 5 square root of 3, negative 5 square root of 3. And then now we have this. Same thing here, since it's already the square, the group that is squared is already isolated. We can just set the two equations. J minus 5 equals square root of 34, or J minus 5 equals negative square root of 34. And now we have two solutions if we add 5 on both sides of each equation. J equals 5 plus square root of 34, or J equals 5 minus square root of 34. Solution set: 5 plus square root of 34, 5 minus square root of 34. And then now we're gonna continue with that two little problems that are applications. These two applications, here we have to estimate the police use formula. So that's a police use formula. To estimate the speed of a car V in miles per hour based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road at the scene of an accident. A police officer measures a car's skid marks to be so that is the length is 181 feet long. Approximately how fast was the car traveling? Round your answer to the nearest 10. That means one digit, one decimal place. Now, all you gotta do, you got the formula V equals the square root of 20 times the length, that is 181. So use your calculator. Now this time you're gonna round it, and that's why you can use your calculator. Well, you can always use your calculator, but in this case you can round. That's 20 times 181. So square root of 3,620. Now taking the square root of this number, that is 60.1664, and then continue. So the rounded value to one decimal place. So you were gonna stop here. It's 1, but because the number after 1 is 6, so it's going to be V equals 60.2 miles per hour. So that would be the speed of the car under these conditions. Here's another example here. Laptop computers are measured according to the diagonals of their screens. Now here, so that means if they say 18 inches laptop screen, that means the diagonal of this laptop is that number. In this case, 14 inches. So 14 inches is the diagonal. A 14 inches laptop has a screen that is 9 inches tall. So the width of this rectangle is 9 inches. How wide is the screen? So the length is what they want me to find. We need to round this answer to 2 decimal places. Now we should remember that is a right triangle. We can use the Pythagorean theorem, that is the diagonal. So if I call this one A, well, let me call it C. That's C. And this side, I will call it A. And this side, I call it B. According to the Pythagorean theorem, we would have C squared equals A squared plus B squared. Well, we identified the sides, so that would be 14 squared equals L squared, which is the length, plus 9 squared, right? So L squared would be 14 squared minus 9 squared, or L would be the square root of 196 minus 81. L equals L equals now let's go ahead and so that's 196 minus 81. Square root of 115. Square root of 115 is 10.72. So that equals 10.72, 7238, and dot. So L rounded to the 2 decimal places would be 10.72 inches. Now let's solve this number 42. It says solve by using the quadratic formula 4p squared plus p minus 6 equals 0. Write a rational solution as an integer or reduced fraction. Write complex solutions in the form a plus bi. For square roots, consider using the math wheel. If there are multiple solutions, separate them using commas. Please, you would type DNE if no solution, or you would click no solution, like that refers to if you're doing it on the computer. Now the equation a the equation 4p squared plus p minus 6 equals 0 is a quadratic equation, right? So a equals 4, b equals 1, c equals -6, right? So we will plug in ABC in this equation solution formula. So P, since the variable is P, equals negative B. B is 1, negative B is -1, plus minus square root of the square root of B squared. So 1 squared minus 4, A 4, C -6. So we have that divided by 2 times the value of A. 2 times value of A is 4. So that is -1 plus or minus. We're going to perform the whole thing inside of the radical. So that is 4 times 4, 16. 16 times negative 4 times 4, -16. -16 times -6, that's a positive number. 96 plus 1, that's 97. So that's square root of 97 over 2 times 4, 8. So we have two solutions, -1 plus square root of 97 over 8. And the other solution, -1 minus square root of 97 over 8. So the same thing in this one, A equals no decimals. So A equals 3, B equals 1, and C equals -3. X, that's M equals -1 plus minus square root of B squared 1 squared minus 4, A 3, C -3 over 2 times A, that is 3. So that is -1 plus minus the square root of, perform the entire operation inside of the radical carefully to get 37 over 6. So the solution set, -1 plus square root of 37 over 6, and -1 minus square root of 37 over 6. That is the solution set. Next problem. The remainder of the problems will be pretty much the same scenario. So let's first we're gonna add 12 on both sides. 4x squared plus 12x plus 12 equals 0. If we divide by 4, that would clear this better. You can do that if it's an equation. So x squared plus 3x plus 3 equals 0. So A equals 1, B equals 3, C equals 3. X will be B squared. So that's 3, negative B. So negative 3 plus minus square root of B squared. So that's 3 squared minus 4. A equals 1. C equals 3 over 2 times A. A is 1. So X equals that's negative 3 plus minus 9 minus 12 is negative 3. So square root of negative 3 over 2. Simplify this because you know square root of negative 3 is I square root of 3, right? So that is negative 3 plus minus I square root of 3 over 2. So your solution set is will be negative 3 plus square root I square root of 3 over 2, negative 3 minus I square root of 3 over 2. And then finally, we got A equals 1 for this, B equals 2, C equals 46, X equals negative B, so negative 2, plus minus square root of 2 squared minus 4 AC, right? A equals 1.